Packing efficiency is the percentage of total space filled by the particles in the unit cell. Since a simple unit cell contains only one atom, the volume of an atom is the volume of a sphere, which is 4 pi r to the third over 3. Remember that the atoms are located only on the corners of the cube. The particles touch each other along the edge. Thus, the edge length L, or side of the cube, and radius of each particles are related as L equal to 2r. Therefore, the volume of the cubic unit cell is the edge length L to the third power. For a simple cubic unit cell, it will be 2r to the third power. The packing efficiency of the simple cubic unit cell is 52%, which means almost half the space is empty. Therefore, the simple cubic crystalline solid is loosely bonded. Now, it is your turn to calculate the packing efficiency of the body-centered cubic unit cell and face-centered cubic unit cell using the number of atoms per unit cell and the edge length in terms of the radius of the atom. You should get 68% packing efficiency for a BCC unit cell and 74% packing efficiency for a FCC unit cell. After knowing the volume of the unit cell, you can actually calculate the density of a substance. You can calculate the radius of an atom if you know the molar mass of the atoms, the type of unit cell, and the density of a substance. Finally, knowing the density of a substance and the type of unit cell, you can calculate the atomic mass of a substance.